In today's note, we are going to be combining the two laws that we learned previously, the sine law and cosine law, as well as our trig ratios, sine, cos, and tan, and apply those to solving application questions or word problems. So the first thing we want to do is just learn a little bit of terminology, and we've covered angle of elevation already when we looked at measuring tall objects or tall things. But just as a refresher, the angle of elevation is if we have, say, a horizontal line, and from that horizontal line, we start going up to our next line. And that angle that's formed there from going from a flat line up is our angle of elevation. Our angle of depression, which we've not talked about previously, is very similar. We still start with a horizontal line, and then we go down. Think of depression, you're going down. So from a horizontal line down and to another line, that angle that's formed is our angle of depression. So those are some terminologies that we may use or you may see in word problems. So now you have a reference to kind of go back, because it is important when you are trying to visualize the situation. So in our first problem, Jill stood admiring a magnificent Douglas fir on the opposite shore of a river. Jill measured the angle of elevation to the top of the tree and found it to be 17 degrees. He then walked 30 feet away. This time the angle of elevation to the top of the tree was 15 degrees. Calculate the height of the tree. So it may seem confusing at first because in word problems you may not get the actual triangle, but there is enough information there to help us draw the triangle. So based on what we're looking at, we know Jill is going to be somewhere here, and she's staring at a tree. So what I'm going to do, I'm just going to draw a tree quickly. Again, you can be as creative as you want. This, if it helps, get into the question, or just let you get some creative juice flowing, or at least let you find some enjoyment in doing these questions. So we have our tree here. You want, but quite simply, all you have to do, if you're not very artistic or you don't really care about that, is that you just can draw a vertical line, and that vertical line represents the height of our tree. So going back and reading the question, we have our tree. We know that Jill measured the angle of elevation to the top of the tree and found it to be 17 degrees. So what that means is that Jill is at some distance away. I'm going to put an X there. I'm also going to connect that with a straight line from the base of the tree, because I know that there is a horizontal distance from where she was standing to the base of the tree. Now, angle of elevation means going from the horizontal up. So her view, similar to what we've done in the past, her view from this horizontal up to the top of the tree, I'm going to draw that line to represent that angle, and now I can write that angle in. Angle of elevation right here was 17 degrees. The next part of the question, she then walked 30 feet away. So 30 feet away from the tree means that we are going backwards. So I'm going to draw another line here. Again, it doesn't need to be the scale because you're going to put the numbers in anyways. But I would draw it big enough so that depending on the picture, you can fit in all the information. So 30 feet away, he then looks up to the top of the tree again, and this time the angle of elevation is 15 degrees. That means if she's standing at that far point, and I draw a line connecting the top of the tree with that horizontal line, this angle right here is 15 degrees. And then this is where Jill is standing. So that's all the information that the question gives us. We can assume that the tree and the ground form a right angle, especially if we're staring at it at two dimensions. So we need to figure out what to do to figure out what is the height, or h, tree. Now, it may be confusing and you may not know where to start. I would start with the very simple things that we can kind of piece together. The first thing that we can do is figure out this angle here, because it doesn't take a lot of calculation, and we should know that in order to form a straight line or a flat line, the angles have to add up to 180. That means if I do 180 minus the 17 degrees that are here, I can get what is that, this blue angle, which is 160. This blue angle is 163 degrees. Based off of that, then if I'm looking at this long triangle on the outside, I can find this angle up here, because again, I know the two other angles in the triangle, and I should remember that all angles in a triangle add up to 180 degrees. So 180 minus 15 minus 163 equals 2. That means 2 degrees is this small angle here. Now I have a triangle where I know all angles on one side, and I have a right angle triangle where I only know one angle. If I'm looking just at this right angle triangle that I see here, I'm going to try to highlight it in red. If I should remember that for a right angle triangle, I can find a side length if I have an angle and another side length. All I need to do is find one of two sides, either this one here or this one here, and then I can use that information in this right angle triangle to find that height. I'm not going to be able to find the bottom side, but I can find the top side here, labeled x, this hypotenuse, because it's shared with another triangle, and I have quite a bit of information in the second triangle. So what I'm going to do, I'm going to draw that second triangle. So this long skinny one, stretched one here, 163 degrees, 15 degrees, 2 degrees, 30. So what I want to do is I want to find this unknown side here, because it's shared with this red triangle. And once I find this side, I can then use my right angle trig to figure out the height. So looking at this triangle here, zoomed in, I can tell that it's not a right angle triangle. And because it's not a right angle triangle, that means I have to deal with sine law or cosine law. So looking at the triangle, do I have all three sides? No, I only have one, so I can't use one part of cosine law. Do I have a sandwiched angle? Nope, I don't have a sandwiched angle because I only have one given side, so I can't use cosine law again. So that leaves me with sine law. With sine law, remember we have to look to see if we have a full pair and half a pair. Now we should be able to see that we do have a half pair here. We have the angle and the missing side that we're looking for. So now all we need to know is, do I have a full pair? We do have a full pair. I have two sides, or this side and this. So the 2 degrees and the 30 feet are a pair. And then the 15 and the x are also a pair. So what we can do now is we can use our sine law. I'm just going to call our pairs A and B just to make it simple. And I can fill in my information from this triangle. So my full pair, sine of 2 degrees over the side 30 feet, sine of 15 degrees, which is paired up with a side length of x because we're unsure. Now with sine law, the first step that we have to do after we fill in our information is cross multiply. So we have x, we have x times sine 2 is equal to 30 times sine 15. Remember, we want to get x by itself. We're going to divide both sides by sine 2. I want to cancel out this multiplication. We're left with x equals 30, 15. Divided by sine 2. And this just becomes a calculation calculator. And when you go through and you do that, you should get an answer of 222.5. I'm going to box that, and that doesn't mean that that's the answer, but that does give us enough information to go through, or we can add that. So I'm going to erase the x because now this is going to be 222.5. Actually, let me go down here. Color code that light blue so we know where that answer is. So that we now know that distance, or how the distance from like your eye level or from the person to the top of the tree. And I can use this to figure out what is the height of the tree, because now I can just deal with red right angle triangle. Red right angle triangle, I know 17 degrees, so I'm just getting this information straight from the picture. I know the 17 degrees. Height, I don't know. I know the 90 degrees, I don't know the bottom length, and I do know that this top length, 225. So using this triangle, there should be enough information here to find that height, which there is. Now, if you have to review or go back to your notes, remember the first thing with right angle trig is labeling your sides. So I have my hypotenuse here, but it's across from 90 degrees. I have my opposite here. Don't get confused with the h. The h just represents height. And then my adjacent. Only two sides that I'm going to be using are the hypotenuse and the opposite, because that's what I'm given and what I'm looking for, and I have my reference. So the ratio that uses hypotenuse and opposite is sine. So formula is sine theta equals opposite over hypotenuse. Sine of my angle, 17 degrees, opposite, I'm going to call h for my height, and hypotenuse is for 222.5. For our notes, remember, or from our notes, the missing piece is on top. You bring the bottom up and you multiply. 222.5 times sine 17 is equal to our height. And when we go through and we calculate that, we should get approximately a height of 65 feet for height. Then we can just put in a therefore statement. So therefore 3, 5. Now this is maybe one of your more complicated questions, because if you look at it, we do have two triangles and they're dealing with right angle triangles and non-right angle triangles. So this is a complicated question, or a complex question, because we're looking at two different parts. That's not to say all of them are going to be like this. It may just be a right angle triangle or just a non-right angle. The key thing is being able to draw your triangle based on the information. I'm going to look at one other example. So in this example, we have a mine shaft that is dug into the side of the mountain at an angle of depression of 30 degrees. On the other side of the mountain, 6.4 kilometers away, a second shaft is dug at an angle of depression of 45 degrees. How long will each shaft be when they meet? So again, this may be a question that if you're into engineering or construction, you may need to know, when are these tunnels or when are these pathways going to meet, or how long are they going to meet, or will they meet? Because you want to be careful of that when you're constructing things or when you're building. If things are going to intersect or somehow meet up. So we're going to work on drawing our triangle first. So we have a mountain, right? So just for the sake of argument, I am just going to draw a mountain here. Again, you don't have to draw the mountain. I think it's helpful. So we have our mountain here, our little top. And the first thing is we have a mine shaft side of one mountain. And we have a mine shaft on the other side. So the first one, it says it dug into the side of the mountain at an angle of depression of 30 degrees. So angle of depression means from a horizontal line going down. A horizontal line going down 30 degrees. On the other side of the mountain, 6.4 kilometers away, so that means that this horizontal line is 6.4 kilometers. It's the direction of the distance across. Second mine shaft is dug at an angle of depression of 45 degrees. That means this one would cut down 45 degrees. I want to know how long will each shaft be when they meet. Basically, I want to figure out what is all this A and all this B. I want to know where those two lengths. That's something predetermined. Back and label my other sides just to help. So basically, I want to find the distance of side A and side B. So first thing we want to do, look to see if there's any information that we can add that's very simple or very simple calculation. So looking at this triangle, I can see that I'm missing another angle here. I should be able to recognize that I can find this angle because this angle here is the third angle of a triangle. All triangles, the angles add up to 180. I can do 180 minus 30 minus 45, which will give me an angle of 105. So down here at the bottom, this angle is 105 degrees. Now you may look at it and say, well, your triangle doesn't look like that, and that's fair. Keep in mind, not all pictures are going to be drawn to scale, but as long as the information's in the right spot, then you're good. So based off of this, I have all the information that I can just plug in using quick calculations without trig. So now it comes down to what trig do I use? Well, we can tell that it's not a right angle triangle, so we can't use SOHCAHTOA or our trig ratios. That leaves either our sine law or our cosine law. Because we're looking for a missing side, I need to have a sandwiched angle if I'm going to use cosine. Do I have two sides that are on either side of an angle? I do not. I only have one side, 6.4. So I don't have a sandwiched angle, which means I can't use cosine law. So the only thing left is sine law. And in order for us to use sine law, we have to make sure then that we have a full pair and a half pair. I can see a full pair here because I have my angle and my side. I then have two half pairs, color coordinate, one red. So I have the angle of 45 and side. Then I have another half pair over here, the angle of 30 and the missing side. So I have enough information to use the sine law. Actually, let's look for side B first. What I'm going to do is I'm going to start with sine C over little c, sine B over little b. So sine C is what I've labeled as my first pair. What you choose to label it as is up to you, but as long as you recognize that that's a full pair. So Sine of the angle C is 105, C is 6.4, or side C. Sine B, or angle of B, is 45 degrees. Little b, we don't know. First step here, once we fill in the information, is cross multiply. I'm left with b times sine 105 equal to 6.4 times sine 45. The next step that we have to do is we want to get rid of the sine 105. So whether you move it across or you divide both sides by it, same. So sine 105, divide on the one side, divide on the other side, cancels out, and you're left with b equals 6.4 sine 45, or times sine 45 divided by sine 5. This just becomes a calculation on your calculator, and you should get roughly 4.7 units is the distance of the first shaft. If we're looking at the second one, we're going to use sine C over little c again, because that's still our given pair. Now, what you can do if you wanted to, you could use your b pair, because we now have the given side for b, as your full pair, and then you still use a as your half pair. Only issue with that is that if you get side b wrong and you do your calculations wrong and then you use it in the next step, you're going to get the second one. So just to play it safe, try to use the given information as much as possible, because you know that should be right because it's given to you in the question. Sine c over little c equals sine a little a. Fill in our information, so we have sine of 105 over 4, 30 over little a, and the steps are going to be the exact same one we had just done, just different numbers. So cross multiply, a sine 105, 6.4 times sine 30, divide both sides by sine 105, a equals out. A equals 6.4 times sine 30 divided by sine 5. Again, this just becomes a calculation on your calculator. Do this, hopefully get the 3.3 kilometers, which is the distance length of side A, or the second. So those are your two lengths, so you can do a therefore statement. So therefore, the two mine shafts are 4.7 kilometers and 3.3. So again, the math that we've done in these two questions is stuff that we've done in previous lessons, so hopefully that's not new. The new thing, or the tricky thing in this, would be drawing your triangles based on the given information. I'd say take your time with it, read through the question, go back, highlight the information, and then try to come up with a visual of it. Think about what it would look like. In most cases, it's going to be two-dimensional, or you can think of it like either being like an overhead view, but it just takes practice and just trying to visualize. Yeah, take your time with it, and then you have to figure out, based on the triangle you've drawn, what type of trig you have to use, whether it's the right angle trig or whether it is non-right angle trig. So it may not, it may be right angles, or it may not be. It's not always going to be. Take your time, make sure you draw your triangle clearly based on the information, and then refer back to your notes for what trig to use.